In this example, we need to calculate the cell potential of a galvanic cell that uses the two half reactions shown below. If you have Ag plus electron gives you Ag, and that's plus 0.8 volt. And here we have Mg2 plus 2 electrons is going to give you 8 Mg, and it is negative 2.37 volt. So first of all, I'm going to write the equation for finding standard cell potential. Equals to standard reduction potential of cathode minus standard reduction potential of the anode. And you know, in cathode we have reduction, and in anode we have oxidation. Where do we find this information? We find it in a table related to standard reduction potential. So whenever we have a number greater than the other, it means that this one is going to be oxidizing agent, and it is going to act as a cathode, and this one is going to be the reducing agent. Oxidizing agent is going to reduce, and reducing agent is going to oxidize. So we have ER cathode minus ER anode. So here in these two reactions, we need to rearrange it in such a way that we have these two electrons in two opposite sides. So I'm going to write Ag plus equals to Ag. So I don't touch the first reaction. Why I don't touch it? Because, as I said, in the first reaction we have reduction. Reduction means absorbing or gaining electron. So which makes sense here. But the second one, it has to be oxidation. So when we are dealing with oxidation, we need to flip the reaction. So it's going to be Mg gives Mg2 plus 2e. And obviously this one is going to change to 237. And here, in order to balance it, we need to make it times 2, because 2 electrons and 2 electrons is going to cancel out, but we don't multiply this number by 2, we just keep it like that. So then, based on this formula, I can say delta ER equals to standard reduction potential of the cathode, which is 0.8, minus the standard reduction potential of the anode. This is the standard reduction potential of the anode, not this one, because that's what you find in the table and has to be in terms of reduction. So we have negative 2.37. So when you calculate it, that's going to give you 3.17 volt. So the overall reaction is going to be 2 Ag plus Mg gives you 2 Ag plus Mg2 plus.